Welcome back to geometry. We're going to do, I didn't write it, chapter 4, section 2, talking about triangles, more about triangles. So I told you we're going to talk more about triangles than you ever imagined could be about triangles. So first of all, you need to know the definition of congruent and not congruent. Congruent is fancy math for the same. Think about Sesame Street. You probably learned this. So I traced an old Game Boy and made two congruent shapes. They are the same. Their angles are all the same and all of their sides are the same. That's the definition of congruence. These shapes are not congruent. Even though those two are the same shape, they're not the same size. And so that means their angles are the same, but their sides are not the same, the lengths. So congruent things have corresponding angles and sides. Okay? So here I have two congruent triangles, and for them to be congruent, then that means corresponding sides and angles are congruent. So A and B and D and E are the same length. They would both get one mark, red mark, to show they are the same. BC is the same length as EF, so they get 2 marks. They're not the same as the other one, but they're the same as each other. This one would get 3 marks because these two are the same. These two angles are the same, so they're going to get 1 mark. These two angles are the same, so they get 2 marks. And these two angles are the same, so they get 3 marks. Now, these two shapes, they're not triangles, but they're also congruent. This is the symbol for congruent. It's equals with a wavy line on top in geometry. And they are congruent, sorta. I didn't do that good job drawing them, but they're turned. So in this one, L, M, P, how you know which angles match and which sides match is the order of the letters, how they're written, that these are congruent. It's not alphabetical or anything like that. It's which ones line up. So that means N is the same as E because they're listed first. So angle N is the same as angle E. P is the same as F because they were written second. L is the same as G because they were written third. And M is the same as H because they were written last. It also means that line NP is the same as line EF because those were written first. Then PL is the same as FG. PL is the same as FG. Then LM is the same as GH. LM is the same as GH. Then the other side, MN or HE are the same. So 1, 2, 3, 4, 1, 2, 3, 4. So by definition, these are corresponding because all angles and all sides correspond. They're the same. Now, here's another theorem for us, the third angle theorem. Here's two triangles, and it says if two angles are congruent, so A is congruent to D and B is congruent to E, then so is the third angle automatically. If 2 match, the third one will, and that really goes back to, remember, they all add up to 180. So that means C would also be congruent to F, and we're going to find out that means the triangles, well, we won't go there yet. Okay. So here's a way to use the third angle theorem. We're told that 55 corresponds to this angle, and this 65 measured angle corresponds to that one. And then y is the same as this 2x plus 30, and we're supposed to solve for x. Well, we can figure out what y is because we know y plus 55 plus 65 is 180, and 55 plus 65 is 120. Why is y not alone? It's being added to 120. The opposite is subtract 120. What you do to one side, you do to the other. So y equals 60. Now, we know that 2x plus 30 equals 60. We substitute it in there, and now we can solve for x by doing the opposite. Y is x on line, so we multiply by 2, and it has a 30 added to it. You start with what's further away from x and move to what's closer. So do minus 30 from both sides. 60 minus 30 is 30. Bring down what you didn't mess with, 2x. Y is x on line, it's multiplied by 2, so we do the opposite. We divide by 2. What you do to one side, you do to the other. Those cancel out. 30 divided by 2, x equals 15. Alright, so now let's talk about some proofs. When we are proving things congruent, then all the angles, if we are proving two triangles congruent, all the sides and all the angles will be equal that correspond. If congruent, all sides congruent, all angles congruent if they correspond. Things we can use in proving it are reflexive, remember that? Symmetric, and vertical angles will be useful. Reflexive, symmetric, and vertical angles. So, here's one that we can do. Can we prove these are congruent? Well, we have it marked that the sides are the congruent. And we know that those two are congruent because they're both 92. Now, but what about the other two? But remember Q? Vertical angles are congruent. So I know that angle Q is congruent to that angle Q. And if two angles are the same, by the third angles theorem, we know the third angles are congruent and that is congruent. So we kind of paragraph proved it. You can read the paragraph proof of that in your book, but if you can just logic through it, I'm happy. Now, one thing I need to tell you guys, I think the hardest part of geometry is chapter 2. Chapter 2, 3, where you're just learning proofs. It's going to get easier. So if you're freaking out because this is hard, calm down. It's going to be all right. All right? With that said, let's do another proof. Okay? Here we have this box. And remember, those triangles mean those lines are parallel. And then we have those lines going across. So we are given that AB is parallel to CD, and we're given that AB is congruent to CD. Remember, that's what that little red line means. And we are told that E is the midpoint of AD and BC. We are asked to prove the triangle ABE is congruent to triangle CED. So we're proving that that triangle is congruent to that triangle. Now then, the first thing we can write down are the givens, remember? So I wrote them all down and said given. The next thing we can say is that because these are parallel and they're being cut by transversals, that we can say that alternate interior angles are congruent, which means this cuts across this angle is congruent to that one. This cuts across here, so this one is congruent to that one. They're alternate interior angles. Then we could say that this angle is congruent to that one by vertical angles. E is congruent to itself. And then we could say that AE is congruent to EB and CE is congruent to EB because we were told they were midpoints, and that's the definition of midpoint. And so we have said now that this is congruent to this and that is congruent to that. And so now that we have, and we already knew that, that this was congruent to that. So we know all angles and all sides are congruent. So we can say triangle ABE is congruent to DEC because that's the definition of congruent triangles. All angles and all sides are congruent. Now, I would normally say math is fun, but I found out that there's another tutor YouTube channel that already uses that. So I have to get a new one to try to indoctrinate you and subliminal message you into thinking that math is fun. So now we're going to change it. It's going to be math is great, and soon you will be believing that math is great too. All right? See you next time.